Good day, everyone, and welcome to my presentation of our research. I am Jensen Marie Romero, your presenter for today. To start off with our introduction, our motivation is to develop an alternative source of energy. And you may be wondering why. This is because, as seen in our first picture in the upper left, according to International Trade Administration, majority of our energy source is coal. These energy sources are utilized to address the energy consumption of the Philippines, where according to Statista research, the electrical consumption is increasing over the past 10 years. The same trend in the electrical consumption can be observed in the following years if this consumption uses coal as major source. It could significantly contribute to the climate change in which we do not want to happen. Energy harvesting techniques have been arising in different studies, and one of them is presented at the lower left of the slide, entitled Energy Harvesting and Wireless Power Transfer Antenna for IoT Application. One of the presented techniques is the energy harvesting from vibrations, which could be done through piezoelectricity. Its noble characteristics have attracted many researchers, as the studies have increased from 1 to almost 1,200 from 2000 to 2019, indicated in the lower right graph adapted from the study entitled A Comprehensive Review on the State of the Art of Piezoelectric Energy Harvesting. The main objective of our research is to design an airport barrier with a single-layer piezoelectric generator driven by aircraft noise in the runway. In order to achieve the objective of the research, it will be accomplished through 1. Create a 3D model of airport noise barrier cutout with a piezoelectric generator using SolidWorks. Next is to test the viability of the harvesting circuit with the piezo element in an multisim. And lastly is to employ a descriptive statistic on the results of simulation and actual testing. Most of the studies in the table have utilized environmental noise in generating energy through various technologies such as the piezoelectricity, while the remaining studies have utilized noise from high-speed railways, harvesting the noise through Helmholtz resonator, and found efficient in energy generation. Various noise has been utilized for energy generation through technologies such as the piezoelectricity. However, very few research have utilized airport noise in order to generate energy using piezoelectricity. With that, researchers came up with an idea to fill the stated gap by utilizing airport noise in generating energy through the use of piezoelectricity. The study was conceptualized using the input process output research paradigm, wherein it is indicated in the input box the necessity of familiarization of designer in electronics, piezoelectricity, and etc. Also, hardware and software requirements are indicated that will aid in accomplishing the study's aim. The process box gives detail on stages of prototyping that involves designing, developing, testing, revising, and finalizing noise barrier with energy generator, which is the output of the study. In accomplishing the research, the method was categorized into two, which is the simulation setup and the actual step. Starting off with the design process of the barrier in SolidWorks, where the barrier is configured to be in an octagonal shape with its full dimension of 12 by 12 by 16 inches. The piezoelectric generator circuit is then designed to have a full wave bridge rectifier as shown in the lower right figure using a normal diode 1N4001G for the conversion of piezoelectric output into DC output. The piezoelectric generator circuit is then designed to have a full wave bridge rectifier as shown in the lower right figure using a normal diode of 1N4001G for the conversion of piezoelectric AC output into the DC. To house the circuit presented in both figures at the lower left side is the barrier's interior, where it has a base with two platforms in a shape of F. The upper platform will house the piezoelectric element and the lower platform for the circuit. For the simulation setup, the circuit will be created in NI Multisim as well as the simulation in the same software. Simulation setup will follow the block diagram as shown, where it starts from a function generator where input will be adjusted. Function generator is then connected to a speaker that will interpret the input sound method. This speaker will be placed in front of the harvesting circuit, and then a measuring tool will be connected at the end of the circuit to measure its output. The input for the simulation, as stated in the earlier section, will be the measured noise level at each site within 6 km radius of runway adapted from the study entitled Effect of Noise Sensitivity, Noise Exposure, and Affluent Status on Aircraft Noise Annoyance with Measurement of Noise Level within the ES 624 and 1331 runway. For the methodology fabrication, the actual barrier cutout will be configured similarly to that of the design in the SolidWorks. The circuit will only be fabricated once the design and the simulation work without any impedance mismatch or components malfunctioning. After that, the testing will be done where two setups will be done, which is the same in the simulation. First setup will be a function generator, again connected to loudspeaker, in which the speaker is placed in front of the barrier where a multimeter is connected. For the second setup, connections will be in the same way configuration as the first setup, but multimeter is replaced with an oscilloscope. So the study have resulted of a design of the airport noise barrier cutout, wherein the design is in octagonal shape with its whole dimension of 12 by 16 inches, and its specific dimensions are indicated in the table. The 3D model of the barrier cutout, together when it is assembled in multiple numbers, is shown in the upper portion of the slide, while the cross section is shown in the pictures below to visualize the interior of the cutout barrier. Gathered output of the circuit testing both for the simulation and actual setup using two different electrical measure devices is presented in the table. Data gathered were found to be identical and is equivalent to 1. For the conclusion and recommendation, the barrier cutout was found to be in an octagon shape with again its overall dimension of 12 by 16 inches. The result during the simulation and actual setup were found to be almost identical, and the results were found to be consistent, having outputs less dispersed within the mean. So for the recommendation, the use of honeycomb structure is recommended to be able to capture more vibration. And in order to increase the output voltage, we can use more piezoelectric element connected in series. And for the increase in amperage, we can use more piezoelectric element connected in parallel. So some of the use reference throughout study is shown in the slide. And that ends the presentation of our research entitled Design of Airport Noise Barrier with Energy Generator, authored by Janzel Marie Romero, Carl Edrickson Victores, Engineer Virgilio Zacarias Jr., and Engineer George Bautista. That would be all. Thank you.